Hi everyone, this is Mrs. Turigno, and this is your first semester exam review for Algebra 1B. This first video will cover problems 1 through 6 from the first packet, and then subsequent videos will cover the rest of the packet. So if you have a particular problem that you would like some help on, you are free to jump ahead to that question, or you may watch all of the videos beginning to end just to get a thorough explanation of all of the problems in your packet. Just remember that your exam is very much based on these review packets, or rather, I guess I should say that the review packets are based on your exam. So if you can get a very thorough understanding of all of the problems in this packet, you will be more than prepared for your exam. Okay, let's start with problem number 1. Problem number 1 is about Josie receiving an inheritance, and she's splitting the money into different categories. I'm going to start by jumping to the end of the problem and paying attention to what the question is actually asking me to find. Here it is asking me to find out how much the total inheritance was worth. So I'm going to start by defining my variable. So I'm going to say that X represents my total inheritance. And that's an important step to take because as we work through the problem, when you're using that X, I want you to know what it represents. It will help you when you're setting up your equation later, and it will help you when you get to the end of the problem to interpret your answer. So even if that seems like an unnecessary step, I really recommend that you do that you start by saying what X will represent. Okay, so the first chunk of money she's putting away into savings. She's doing 2/5 of her total inheritance. So I'm going to say 2/5 of X is going into savings. And then she's got 1/3 of it going towards U.S. savings bonds. So I'm going to spend 1/3 of X on savings bonds. 1/4 of it is going towards a car. So here's that, 1/4 of X. And then I have $36 left over. Now, when I put together all 4 of these chunks of money, this should give me the total inheritance. So I'm going to add these 4 terms together and set them equal to X, the total inheritance. Getting that problem set up is probably the trickiest part, but those fractions aren't very fun either. So let's talk about how to get rid of those fractions. What I would do is I would look for something that would cancel out the denominators of all 3 of these. That means I need something that 5, 3, and 4 all divide into evenly. I happen to know that that number is 60. Now, if you didn't know that, it would always be safe to just multiply those 3 numbers together. In this case, it happens to work out to be 60. That's not always the case. It might work out to be a bigger number than what the lowest common denominator really is. But that's okay. You can still work with that number. So I'm going to take everything in this problem and multiply by 60, including these numbers at the end that are not fractions. Okay, that's important. When I multiply 60 times 2/5, here's how I would do it. I would do 60 times 2 divided by 5. That's 120 divided by 5, which is 24. Then 60 times 1 divided by 3 is 20. 60 times 1 divided by 4 is 15. And again, don't forget you also have to multiply this 60 by the 36. When you're working with an equation, you have to multiply by every single term in the equation to keep things balanced. And then I also have to multiply by this X down here in the end, so that's going to become 60X. Probably once we get to here, you're okay with solving it. But from here, all you would need to do is add together your like terms here. And that's going to give me, let's see, that's 44X plus 15 is 59X. Plus 2160. And that still equals 60X over on the other side. There we go. Okay. Now I'm going to subtract this 59X from each side. And I'm left with 2,160 equals 1X, or just X. So what does that mean? What does that tell me? Well, way back here we said that x is the total inheritance. So if I have that x is $2160, that means her inheritance was $2,160. Okay, let's go ahead and move on to question 2. Question 2 is very similar to question 1, and I'm going to set it up much the same way. Start by defining my variable. This time my x is going to represent the total number of students at Waterfront College. So x is total students. Okay, so I have 1/4 of the total students with a healthcare major, so 1/4 of x. I have 3/8 of the students with a technology major. I have 1/3 of the students with neither as their major. Okay, neither's not really a major, but. And then 42 students that are undecided. Remember that what I'm adding together here are groups of students. So when I add together all of these groups of students, that should equal the total number of students at the college, or x. Okay, this time I'm looking for a number that 4, 8, and 3 would all go into. And I can think of 24 that would work. But again, if you couldn't come up with 24 off the top of your head, you could always just multiply 4 times 8 times 3. That would give you a much bigger number, but it would still work for solving the problem. Okay? So now, 24 times 1 divided by 4 is 6. 24 times 3 divided by 8 is 9. 24 times 1 divided by 3 is 8. 24 times 42, oh, I have to cheat and use a calculator for that one. 1008. And then don't forget to do 24 times the x at the end as well. Okay, that just cancels out my fractions for me so that I can move forward. Okay, now I'm going to combine these like terms. So 6x plus 9x plus 8x gives me 23x plus 1008. That'll equal 24x. Subtract this 23x from each side. And I end up with 1008 equals x. Which again, I can refer back to where I defined my variable back here. That means that there are 1008 students at this college. Now I want to point something out because something similar happened in problem 1, where at the end of the problem we ended up with just 1x here. And so some of you might be noticing that this number always appears to be our final answer. Be careful with that assumption because that's not always true. Sometimes you could end up with a 2x or a 4x or an 8x over here. And then you would have to remember to divide there for that last step. So just be careful not to jump to conclusions. Okay, let's move on to question 3. Question 3 is just asking for the solution to this equation. That means you're just solving. It's just solving for x. What I want you to be careful of here is this 2x is not directly in front of the parentheses. So that 2x is just going to stay the same. It's just going to stay a 2x. The only thing that gets distributed here is this negative sign. So that's going to turn that 4 into a negative 4. And it's going to turn that minus 5x into a plus 5x. And then we still have it equal to 17 on the other side. Okay? From there, I can combine my like terms. 2x plus 5x is 7x. Minus 4 equals 17. Then I would add 4 to each side. I'm going to move up here. That's going to cancel out those 4's, and I'll be left with 7x equals 21. And then divide both sides by 7, and you end up with x equals 3 for your final answer there. Okay? And you could always go back and check your work. You could always put that 3 in there and say, okay, 2 times 3 is 6, 5 times 3 is 15. So then 4 minus 15 is negative 11. 6 minus negative 11 is indeed 17. So that's one way to check your answer at the end of the equation solving. Okay, on to question number 4. Make sure you can see okay. There's nothing really that I can do here on this left side. There's nothing to simplify, nothing to combine. But over here I have another negative sign floating around outside the parentheses. Again, be careful that you don't distribute that 3, because that 3 is not being multiplied by the parentheses. I'm going to rewrite this first side of the equation here. And then this negative sign will distribute. So that's going to become a negative x and a positive 8. Because remember, a negative turns a minus 8 into a plus 8. Now over here, I have a positive 3 and a positive 8 that I can combine. So this side is still negative 2x plus 5. And over here, I'm going to end up with negative x plus 11. Now our job is to get all of the x's to one side and all of the numbers to the other side. So I would probably add 2x to each side at this point. There's a couple of different ways you could go about that next step. So if you didn't take that step, that's okay. And again, I'm going to move over here. Those the negative 2x canceled out with the positive 2x, so I'm left with 5 on the left side. Negative 1x plus 2x gives me positive 1x, or just x, plus 11. And then let's subtract 11 from each side. So I end up with negative 6 equal to x. Okay, and that's it for question number 4. Question number 5. Question number 5 is one that I see a lot of students overcomplicating. Okay, this is just function notation. So this is like saying that the name of this expression is g. And right now, g has x's in it. And this wants to know, what would that expression equal if instead of x's it had a 5 in it? So I'm just going to take this expression and replace all of the x's with 5. Here's what that would look like. 32 times 5 minus 12 over 5 minus 3. Okay? A lot of the times when we get to this step, students will want to distribute this 32, which there's absolutely nothing wrong with. You certainly could distribute it. You guys have been so well trained with the distributive property. However, I want you to notice that here in the parentheses, I just have 5 minus 12. I could go ahead and subtract that and then avoid having to do the distributive property. 5 minus 12 is negative 7. So this is going to end up saying 32 times negative 7 over, and then 5 minus 3 is just 2. Okay, 32 times negative 7 leaves me with negative 224 divided by 2 is negative 112. And that's it. That's just your final answer. Okay, so those ones you're really just evaluating. Okay, you're really just plugging in a number and seeing what you get for your answer. Okay, let's get the last one done on this page, which is very similar. Again, p of 20 just means to take this 20 and put it in place of x here. So I'm going to say 3 times 20 times 20 minus 12 over 8. Okay, just rewrote this expression with 20s in place of those x's. Okay? Well, this here, 3 times 20 is 60. And again, if you really wanted to, you could distribute 60 to the 20 and the 12, but I would probably rather just do 20 minus 12 and get 8. So 60 times 8 divided by 8. If you're really quick here, you'll notice that those 8s would just cancel out, but If you didn't catch that, that's okay. You could just do 60 times 8 is 480. Divided by 8 brings you back to 60. So that would be your final answer there. Okay, that's it for this page of your review. Stay tuned for page 2.